All right, so we're about to dive into this really fascinating shift happening in artificial intelligence. We tend to think of AI as these huge, power-hungry brains living up in the cloud. Well, I want you to forget all that for a minute, because we're going to see how all that intelligence is moving to the edge, to devices so tiny they could literally fit on a coin. This is the world of edge AI, and its, frankly, mind-blowing counterpart, TinyML.
So let's start with the central puzzle here. Think about it. How can a computer the size of a coin make genuinely smart decisions without ever talking to the cloud? It feels like it shouldn't work, right? We've been taught to associate AI with these giant server farms and basically infinite computing power. So how on earth do you cram that kind of intelligence into something so small, so efficient that it could run for months, maybe even years, on a single tiny battery? That's the big question we're going to unpack together.
Most of the AI we interact with every single day lives somewhere far, far away, in a massive data center. It's kind of like this digital oracle we send our questions to and then we wait for an answer. But that whole model, it really starts to break down when you need that intelligence here, in the physical world, right now. Think about a factory floor, or a smart home sensor, or even a medical wearable. The real world doesn't have time to wait for an answer from the other side of the planet.
So to really get why this shift to the edge is so important, we first have to get a feel for the problem it's solving. For years, the cloud has been this amazing central brain for everything smart. But it turns out, when you try to connect millions of tiny devices to it, you start bumping up against some really hard physical limits.
And here are the big three frustrations with that cloud-first model. First up, latency. We're talking about the delay it takes for data to travel to the cloud and back. This can be hundreds of milliseconds, sometimes even seconds. Now, that might not sound like a lot, but for a self-driving car or a critical piece of factory machinery, a second is an eternity. Then there's power. Oh man, the power drain. That little radio sending data back and forth, it can chew through up to 80% of a device's battery life. It's a total battery vampire. And finally, privacy. Every single time your personal or operational data leaves your device, it's out there, vulnerable. For the Internet of Things, these aren't just little annoyances. They are absolute, fundamental deal breakers.
Okay, so if sending every little bit of data to a central brain is the problem, what's the solution? Well, it's a huge paradigm shift. We have to fundamentally change where the thinking happens. We've got to move the intelligence from the central core out to the edge.
And that right there is the core idea of edge AI. Think about it this way. Instead of every little sensor in the field having to ship all its raw data back to some central headquarters for a decision, what if we gave them a local manager, someone on site? This manager is a processor right there on the device, and its job is to do the initial analysis and make immediate decisions. And just like that, poof, our latency and privacy problems start to shrink a lot. But wait, we can take this idea even further. What if the device isn't just a machine on a factory floor, but something incredibly small, something running on a tiny coin cell battery? Well, that's where TinyML comes into the picture. This is the amazing subfield of running AI models on extremely low-power microcontrollers. So if edge AI is like giving our device a local manager, TinyML is, well, it's more like giving it an autonomous nerve ending. A single sensor that can feel, process, and react all on its own, sipping just milliwatts of power.
Okay, so a really common assumption people make here is that TinyML is just about, shrinking things. That you just take one of those massive cloud models, run it through some kind of compression algorithm, and presto, a tiny model. But is that really what's going on? Is it just about squeezing?
Well, the reality is actually way more elegant. This is a seriously sophisticated field of engineering. It's not just one trick. For instance, there's a technique called quantization. You can think of this like using less precise numbers. Instead of using super detailed 32-bit numbers for every single calculation, maybe you use simpler 8-bit integers. It's a bit like rounding, and while it's less precise, it is dramatically faster and way more energy efficient. Then there's something called pruning. This is where you intelligently snip away the least important connections inside the neural network. I love the analogy of a gardener trimming a bonsai tree. You're just keeping the essential, beautiful form. And maybe most critically, there's hardware co-design. This is where the engineers designing the AI model and the engineers designing the silicon chip work together from day one, optimizing each one for the other. So you see, it's not about shrinking something big. It's about designing something to be hyper-efficient from the absolute ground up.
And honestly, this is the single most important idea to take away. The real revolution here isn't just about where the computer is. It's about transforming raw, messy sensor data into clean, meaningful information right at the source. We stop shipping terabytes of noisy, useless data all over the world. Instead, we do the thinking locally and only send the answer. That right there, that is the fundamental shift.
Okay, so this all sounds great in theory, right? But what does it actually look like out there, in the real world? Let's check out 3 examples of this intelligence in the wild. We'll start with some heavy industry. So picture a giant power transformer out in a substation. You know, the kind of thing where if it fails, a whole region could go dark. The old way of doing things would be to just stream every single piece of data from it. Oil temperature, winding temperature, voltages, currents, you name it, and send it all to the cloud. It's just a constant, overwhelming flood of raw numbers. But the edge AI approach is totally different. You put a small, smart device right there on the transformer, and its job is to intelligently sift through all that noise right there on site. And what's the result of that local intelligence? Well, a deep learning model running right there at the edge can predict a failure in that line current with over 90% accuracy. That's its R-squared score, for those who are curious. Think about what that means. It's not just sending a dumb alarm after something breaks. It is forecasting a problem before it happens. It takes that massive flood of raw data and turns it into one single critical piece of information. Hey, you should check me out.
Okay, for our next example, let's bring this idea from the power grid a little closer to home, into our smart buildings. I mean, just think for a second about how much energy is wasted heating, cooling, and lighting up empty rooms.
It's a huge problem. But by using local IoT sensors and AI to figure out in real time which rooms are actually being used, smart buildings can cut their energy use by 20 to 40%. That is a massive improvement. And it works because the intelligence is local, the decisions are instant, and the impact is just enormous.
All right, for our last example, let's zoom all the way in. I mean, way down to a single doorway, because this is where we can see the true elegance of TinyML in action.
Get this. This entire intelligent pipeline runs on a single, tiny chip. So, here's what happens. First, it senses. A simple time-of-flight sensor just captures a 4-second sequence of distance data. That's it. Next, it pre-processes that raw, noisy signal right there on the microcontroller, cleaning it up. Then, the magic happens. It infers. A tiny neural network, specifically a 1D CNN model, which is perfect for finding patterns in time series data like this, classifies the motion. It figures out, did someone enter, exit, or just walk by? And finally, it acts. It sends only the final, simple result, like one person entered, over a low-energy Bluetooth signal. The whole journey, from raw physics to useful information, happens right there on that one little chip.
Okay, so here's where it gets really wild. This is the payoff. How much power do you think that whole intelligent process takes? Just 16 milliwatts on average. I mean, that is an astonishingly small amount of energy.
And what about memory? How much space does the model take up while it's running? A measly 26 kilobytes of RAM. That is literally less than a simple text-only email.
And how fast does it make that decision? The whole thing, the inference, takes just 275 milliseconds. So it's fast, it's tiny, and it's incredibly low power. That is the promise of TinyML made real.
So after seeing all of that, what are the big ideas you should walk away with? Let's try to distill everything we've talked about down into a couple of powerful mental models you can add to your toolkit for thinking about edge AI.
Okay, first mental model. Always think in terms of data versus information. The edge is basically a filter. Its whole job is to stare at the chaotic, noisy physical world and translate it into clean, high-level information. It doesn't send the entire raw recording of a meeting. It just sends you the bullet point summary.
Number 2 is a really powerful mindset shift. Constraints drive innovation. In the world of TinyML, having almost no power or memory isn't a bug, it's a feature. Seriously. Those limitations are what force engineers to be so incredibly creative and to come up with the kind of elegant, hyper-efficient designs we saw with that doorway sensor. It's innovation born out of pure necessity.
And that leaves us with a final, really big question to chew on. For years, we've been building this Internet of Things, right? Basically connecting a bunch of dumb sensors back to a smart cloud. But what happens when we flip that entire model on its head? What does our world look like when it's not just an Internet of Things, but an Internet of Intelligences? When it's filled with billions of these tiny independent intelligences all sensing, understanding, and acting on their own little piece of the world, that's the future that Edge AI and TinyML are busy building right now.